who's our co-founder. Nice to see you, Vinod.
Hey, Francois, good to see you. Happy New Year.
Well,
And
thank you. I'm excited to looking forward to 2026 and what's going on in the AI market. And you recently put out a blog post on your predictions, and we want to kind of dive into a little bit more detail as to what those predictions mean more broadly for the market and for us at Neubird.
it makes sense. I mean, there's a lot happening in this agentic AI ecosystem. Well, I just highlighted a few trends that we're seeing of late, and a few also the trends that we are heavily invested in, and the ones that we are going to be developing in 2026. Okay.
Yeah, so 2025 was really the year of coding agents, wasn't it? Right? The first use case to really take off in a massive way. And I think this year it's going to be the year of catching up with all the other job functions that go with coding. So we're very much focused on the SRE job. And today we'll talk a little bit about how these agents are going to be collaborating. So one of the topics you brought up was the concept of agent pipelines.
Yep. Yeah, so I think 2025, we no longer had to explain to people what agentic AI is. We didn't have to explain how the system works, and even some of the security aspects that we had to talk about earlier on, we never had to delve into it. And the systems are becoming more and more sophisticated. There are a lot of agents that are that are vertical agents that are focused on one specific task that they do very well. And it is hugely interesting to see how to tackle on a large complex program or a large complex problem and break it up into bite-sized chunks and to kind of build an agentic pipeline which will use the best agent for a specific job, how to keep track of the task that is given to each agent, how to keep track of its state, how to bring it all together, and finally solve a really complex task. I mean, mind you that this particular statement, there is nothing new about it. For example, the cloud code is going to go take a task and do it and bring it to completion. What we are talking about here is kind of a declarative language to tie together various agents, out of which one of them could be cloud code, and to bring a more complex scenario into and to complete and to go full circle on a very complicated scenario. So, I will talk a little bit about how what we see happening in our incident response world as to what that means and how that can be described, and some parallels on how we have seen the systems in the past evolve, where we have seen systems like Terraform and the bring up being a declarative language and and used to kind of bring up complex systems to chain them together and to also kind of do source control, version control, and to be like it's well understood, it's well documented as to what a pipeline does, and that's what we want to bring about.
Yeah, so there's a lot to unpack there. Um, One thing that sticks out to me is, the agents collaborating. It's a long-lived process, right? We're in the incident response space, and there are very specific things that need to happen between the alert being fired and the problem actually being resolved. There's humans in the loop, of course. There's production systems, and agents have to interact amongst themselves and along with the humans. And so it's more than just, a couple of agents talking to each other. And I like your the use of the word pipeline, and it really this idea of declarative languages are great for composable kind of systems, right? And so I think, I might be reading between the lines a little bit, but I think that's kind of the vision that you have for using declarative languages to create composable workflows that SREs can implement through AI that combine multiple agents, coding agents, our agent, maybe a DevOps agent in the future, with all the things that make up a production change.
Yeah. Yeah, I think the way to think about it, it's not so much as agents talking to each other, but it is to agents producing the right context for the next agent down the pipeline to be able to consume. So there is kind of like there is a context that goes as an input and a context that comes out as an output, and that serves as an input to something else which is well versed in that task. An example could be like the AI the SRE agent actually produces a root cause and produces a stack trace and the line of code where the stack trace, where the exception was hit, because that is what it found in its diagnosis. So that is a great context for a coding agent to pick up on and to take it to the next level of submitting a PR on that specific problem.
Let's show a quick example. I have a presentation that kind of highlights pretty much what you just described, and so maybe it'll help the webinar attendees to kind of visualize what we're talking about. So very specific to our world of SREs and helping them not only uh, respond to an incident quicker by providing real good information, root cause analysis to solve the problem. We want to get into the resolution part and helping with this automation. And I think that's a great use case for this agent pipeline because it addresses some of what we're hearing from our customers, right? There's usually multiple aspects to the incident response that involve 6+ tool use, right? And so there might be an incident management system, there's a observability stack, there's some automation, maybe there's code, there's a DevOps pipeline, there's all these different aspects, and there's a lot of context switching, and we have a problem where we're not really fixing the underlying problems because we're so busy going through this kind of reactive model. And so the image that I have for agent pipelines is one where we carry the context, as you said, from the initial incident to the identification of the root cause, so the intelligent detection, and then we automate the orchestration of creating the issue, and it could be a different case. In this case, we're going to talk about a code change that needs to be deployed to fix the underlying issue that we found in production. It could also just be a run book, an automation. I was just talking to a customer today that mentioned that they have these set of run books for the fixing common problems they have with the database. So they would like us to invoke those run books, and then verifying that the problem actually got resolved. And then over time, actually getting away from this constant patching through automation by identifying trends. But to get back to this example, the scenario that I had in mind is something that we see a lot, right? A pod crash loop back off. And a lot of our customers are Kubernetes customers. They see this all the time. And Hawkeye is doing a phenomenal job at identifying the actual root cause, because anything could cause a pod to crash. And in this example is a very simplified example, so people can wrap their heads around it. The root cause is a PVC that's overflowing with data because of some log retention. And so this Hawkeye does today. But the idea of the agent pipeline for us, one way that we could see it come to fruition for our customers is Hawkeye can then open an issue on the GitHub repo that has the Terraform for this PVC or the YAML file. Basically, a lot of our customers are using GitOps, and we can pinpoint the right Git repo as part of our investigation, open a ticket on this repo, open a GitHub issue, and then follow that GitHub issue as the agent picks it up and does the resolution. So some of these agents can actually automatically handle these GitHub issues. We have an MCP server, so that agent, if it needs to, can ask follow-up questions to Hawkeye to find out more about what else is going on in the environment if needed. But eventually that PR would be merged and some deployment pipeline would happen. And by orchestrating all this, we can actually close the loop and follow everything along and actually verify that the fix was made, and then close the Jira ticket or ServiceNow ticket, whatever incident management system is in place. So this is an example where you're having multiple agents potentially with humans in the loop, because PR can be reviewed and merged by a human. And we're leveraging existing kind of systems like GitHub and to automate an end-to-end process.
Yeah. So I mean, you captured the salient points, but and that's a good example of a complete chain. So the way we're thinking of it is that what you've described here is somehow has to be described to us or an agentic system as to what constitutes the pipeline and how do you make all of this happen. So it is that declarative language, as well as the support for the implementation of that pipeline is is kind of interesting. And here, essentially, what we want to do is to come to a full circle on the job of the person doing that diagnosis, the SRE that is involved there, to take it to completion, where not only is the issue diagnosed, but the actual code fix is submitted and the system is updated with it. And so the language that should specified should detail out the steps, the agents that are involved, in the specific agents here that you have is really a coding agent, the SRE agent, and likely a human in the loop too, that perhaps goes and approves that PR that has been generated by the GitHub Copilot and marks the issue as closed. And then finally, it's put into a system of records such as ServiceNow, where you have the full chain that is documented as to why this entire PVC was resized, what had happened, what were the issues, and that serves as reference for the future.
Yeah, so it brings me to this idea of a declarative language, and people may not know we have something called Rail, stands for Raven AI Expression Language, which is currently in our product and is a declarative language for our investigations that looks a bit like a state machine and is written on the fly by the LLMs to dynamically create a investigation plan and execute the investigation, including querying backend systems and filtering data so that we're sending just the right context back to the LMs. And so building on that, this idea of using a declarative language like Rail for pipelines that can be composed out of reusable parts, I think makes a lot of sense, because most of our customers have some form of source code repository, some form of a pipeline, a CI/CD system, right? It might be GitHub Actions, it might be Argo CD, it might be any number of tools. And I think, the idea is you should be able to create these orchestrated workflows without having to do a lot of coding or configuration and just simply compose the reliable parts through this intermediary layer, which so in my mind the user would just describe what they want, and then we in the back would generate this. Just like today, customers don't really see our Rail notation in the background. They just see the results and they can follow along the investigations. So to me, that would be kind of a similar vision here where we can, in the background, take the description of the workflow and then bring back a visualization of that workflow that the customer can follow along. And in the background, we're using this declarative, agent pipeline language.
Exactly. So the way it would be is that the actual requirements of the pipeline would be specified in natural language, which in the back would generate the a definition in Rail, which you should think of similar to like Terraform, but tailored for agentic workflow, um, and backed up by real states. And that in turn would generate a diagram. Think of like a mermaid diagram, which has got the exact workflow that is described. And as time goes along, that diagram keeps updated for a specific pipeline that is in action. Um, and then you would be able to go in and get the results from any one of those agents involved in the pipeline.
Yeah, and I think, the way to implement things has changed so much with AI, and the user experience is also changing. And I know, you're a big believer in that, right? Where, we don't want folks to be configuring rules, static rules, and we want them to describe what they want. So this is a good example of how, with a bit of structure and a composable set of really rock solid components, so interacting with GitHub, right? We can have a that composed with interacting with the CI/CD systems, right? And so it's plug and play, and then the user can just say, I want a pipeline with this GitHub, this CI/CD system, and this coding agent, and then Hawkeye can just make it happen out of these really kind of solid parts.
Correct. Yeah, you should also think of like each of these agents as being like, or even at some point, like parts of these agents being modules that can be swapped out, and
Yeah.
for based on cost, latency, and the actual results that they produce, and the entire pipeline can be, it is version controlled and it's reusable, and so you can share these pipelines across teams, etc.
Okay, and
Yeah.
are we ready to shift gears and talk about the second topic that we brought up?
Yeah.
So in that article, you brought up something that I think is very interesting, and we had a discussion, and I built this picture based on our conversation of this, what we were calling the context engine, and how fundamentally, when AI started, everybody started talking about RAG, right? And RAG was the way to retrieve information through a vector database. And so actually, I learned about vector databases before I learned about LLMs because people were talking about it so much.
Mhm.
And to me, it's, after a few years, it's clear that, it the vector database has its use, but what people really need to be considering in their architecture is how to expose context from raw data, right? And I'm talking here, in our case, it's log files, it's unstructured data, but it's also structured metrics data, time series data, configuration information. But for anybody building an application, they used to have this three-tier architecture that neatly separated the front end, the business logic, where you had to encode your business rules, and then the database. And with LLMs, you know, some of the UIs are actually going away, and that's probably like a conversation for another time. In our space and observability, that might be a little controversial. But we do see people needing fewer dashboards, for example. And in agentic world, you don't need as many UIs. Agents can just talk natively to the data in a very abstract world, right? They don't need user interfaces. Humans are very visual creatures, but the LLMs are language creatures. But the idea of a context engine is very interesting because you have to solve different problems. And so there's the collapsing of the rules in your business logic and the data. So both are really treated as context because you've got a reasoning engine that's got basic, knowledge of the world, basic business sense, basic understanding, and then you're injecting your business specific context. And some, you'll hear, I just heard Satya at the World Economic Forum mention that, companies will have their own LLMs with their businesses encoded in them. And that's great. So that's just a form of, embedding that context directly into the LLM. But the logic and the data are getting into the context of the reasoning engine, and how you do that really matters. So I know this is a really key to how Hawkeye is able to achieve very high accuracy. Hawkeye is the name we give to our agentic SRE, that's for those who don't know. So I just love to get your thoughts on, the context engine, the concept of a context engine, and how we leverage this, and how you see, this becoming part of the architecture for other agentic systems.
Yeah, I think the picture that you have there kind of describes where the classic three-tier application in the back, source for data, some business logic, and a UI to show it. And that's kind of when you morph it into like an a kind of an AI-based system or agentic AI-based system, or even like any the end goal of that, your application might be the same, but it's going to be built a little differently. And the data layer that is out there is no longer something that it looks like a SQL database. It could be one, but overall it is perhaps a layer over all of your data sources.
Yeah.
And that is the key. The key here is that the context is king. Context is what actually will make your the output from actually to the application and to the LLM. That is what the extracting the relevant data pertinent to a specific scenario that is based on your data sources, with data directly coming from the data sources. That is key. And that intelligent context engine, which sits on top of your data, is going to become, like, we think that's going to become a primitive by itself. So that is going to become, you're going to be selling context engines for enterprises, and this it will just sit on top of enterprise data where you can build your applications on top of that, right?
Yeah, it's very interesting. And, it reminds me of this conversation I had with a former colleague recently where he was saying, even at the MCP layer, there needs to be a gradual reveal of the tools, because you bring in a few MCP servers and the agents have too much to deal with, too many tools.
Mhm.
And, it's basically, he was saying that it should be in the protocol this idea of, a kind of a slower reveal and discovery of the tools that's more gradual. And I thought that was a kind of an interesting perspective, but in my mind, MCP is just the protocol is not necessarily the place to do it. It comes down to good design. So just like, we had relational databases for how many years now? 50 years. And you still need a professional to design your relational database. And it's a kind of a domain specific, use case specific thing. And there needs to be careful, crafting of, an AI friendly context engine in my mind. So it's not to me, it's not a protocol thing, but it's maybe the protocol supports this. It's more of a, how do you design a context engine that's domain specific that reveals just the right context at every step of the reasoning process. So you're kind of building it specific to a use case. And there might be tools that allow you to design these and build them reliably. And I agree with you, it's got to be a polyglot type of data system.
Yeah.
But it's kind of a interesting concept. I think people have to think through, and with microservices, there was something called domain-driven design. This is not very that different, right? You really need to design your how you're revealing data to the LM, your context.
Yeah. So it's true that yeah, I agree with a lot of those points. It is the context that is provided to the LM. It should be surgically crafted. It should not be a dump of a lot of information, but the information that is most relevant, and that is an art. I'm not too much of a fan of the to make it very rigid as to what goes in and out. It has to be fairly malleable and has to be a little, it has to be free flowing in a lot of ways. The but and the it is just the a description of what goes into the context engine is also important, right? So that's where I think that the applications that manage to do that um, will have a better context that's coming out of the context engine. Um, so yeah, what comes out depends on what goes in. Um, the the what we obviously what to what you said earlier is right, a kind of a iterative discovery process of what is available out there, and for us to choose the best combination of the data that's available out there, most relevant to the problem at hand, and to craft the output in such a manner that is most easily actionable by the LLM. And that's where the secret lies, right?
Yeah, I like the word malleable because that's kind of the biggest difference from the past. It's because every data interface used to be pretty much built for a very specific thing. And so, with AI, the thinking is fluid and you're not like hard coding any of the ways the data is going to be used. So you need this flexibility in letting the AI go find the data that it needs in the format. I mean, the format probably doesn't matter as much because they're so flexible. But basically, it's all in support of this new um, way of consuming data that is this autonomous reasoning engine that the LLM agent is.
Yep.
So really fascinating. One last thing before we go, and this one will be quick, is, the third prediction that you had is about this eval framework kind of hacking that's been going on, right? And I know you're a very pragmatic architect, and we we have a lot of models that we use in Hawkeye. So we use a squad of models because there's different tasks in a pipeline for accessing and filtering and processing data and reasoning. So there's a every step of the way we need to pick the right model for the job. And I don't think we ever look at the benchmarks necessarily that are published by all these model providers, because it seems to me that the model providers are doing reinforcement learning to score really well on these benchmarks. And so I'd love to just briefly hear from you how you think about when a new model comes out, how do we actually
Yeah.
benchmark it against our use cases?
Yeah. You touched upon Rail earlier on. So that is what describes pretty much the our entire what we call a filter chain, each filter being a small unit of work. And the each filter is may or may not interact with the LLM. If it does, it will interact with the LLM that is most suited for the task that the filter is performing. And so we need the best and how do you what is the definition of best there, right? Now, mind you, it's not really what we have here is a prediction. It's more like a kind of a practical approach that we use for our evals, which is really these are the trade-offs that you have to make in a lot of ways, right? So you need in the end you need a the end result to be of high quality, and there can't be much of a compromise on that. But it's not a monolith that we have. We have a whole chain with there are it's composed of like a lot of filters, and each one of them when they are interacting with the LLM, this is the three axes that we deal with, which is we talk about in each step what is the importance of like the speed, the cost, and the quality, right? If somebody is looking at the doing a kind of interact in an interactive mode, interacting with our AI agent, it's probably if the answer takes like 30 minutes, it's not a great thing. But on the other hand, if it has done something offline, or if it is processed in the background, if it's enriched in the background, then you can compromise a little bit on speed and deliver more on quality. And at all times, cost is also an important factor, right? So that's kind of our evals differ a little bit from we have the our end goal is always quality, but these are the three axes that we kind of control. Um, and in order to kind of deliver the best product for our customers.
Yeah, and at some point, quality doesn't get any better, right? You have the right answer, you have the right answer. So then it's like,
Yeah.
okay, I don't need to get that answer and pay more for it, or have it take longer. So it's kind of, to me, it's you start with getting the right answer, and then you try smaller and smaller models that are faster and cheaper until you stop getting that answer that you really need.
Yeah, I mean, think
And
of it this
that's
way too. Like, you've got code generation models, and that's we use a bunch of them in our chain. They've got to be of the highest quality.
yeah.
And then you have some of them are like toward the end, like the summarization models. Now, there are a lot of the smaller, and there are a lot of the models that are faster, and they still do the same. They can perform the same job as and sometimes the summarization from a nano can be as good as from a cloud. So it's not it's there. That's where these axes play out. Yeah.
Yeah, and it's part of what I tell people, there's many other reasons, but oftentimes because we have an MCP server, we talk about integrating with coding agents, and people inevitably ask, oh, well, why don't I just connect my coding agent to MCP server for Datadog and this other MCP server? And I think we covered part of the reasons why in this call. First, you need to orchestrate the whole process. So there's an actual alert. You can't be sitting there at your coding agent waiting for an alert and then, asking it to do things. Second is the context engine concept. You really need the right context. Uh, but third is this, like when you're using a coding agent, you have one model, and it's usually the best model because you're coding. And you're going to burn through so many tokens if you don't have the right context engine that's just giving you exactly the content you need. And you're using Cloud 4.5 Opus to do tasks that are silly, easy tasks that, a 3B model from Llama could do for, 1,000th of the price. And so
Yep.
that's kind of what I find, is kind of a key, sorry, that's that's what I find is one of the key reasons why, agents that are task specific can be optimized by combining models, where having a general purpose tool like a coding agent is not the right approach for building these complex systems like an AI SRE.
Yep. That makes sense, Transfer. Um,
Thank you, Vinod. This was a great conversation. And for anybody that, wants to learn more, you can find us at Neubird.ai. Find us on LinkedIn. Connect with us. We have at reInvent, we launched a on-demand service. So you can go to AWS and to the marketplace and find our on-demand service there and just start using Hawkeye. And we're the only ones that can allow you to do that because we're that confident in the quality of the analysis that we produce. And so I encourage you to do that, or just go to our website and contact us if you want a deep dive on the solution. Any last words, Vinod?
no, thank you. Thanks for doing the slides. Thanks.
Yeah, thanks everyone. Thanks for
Bye.
attending.
All right, bye.